Algebra 1, Lesson 74, Scientific Notation. All right, I'm going to skip the explanation of what this is and what it's used for because we're going to talk about that in class. And I'm going to go straight to the problems and how to get this done. Because I realized I've been making you guys a lot of 10-minute videos. I think you deserve a short one. So, the goal in scientific notation is to move the decimal point behind the first number that is not 0. And then we have to keep track of that movement and represent it by multiplying by 10. So, in this first example here, we have 0.000316. And I want to move this decimal number behind the first number that's not 0. The first number I see that's not 0, 3. So, I want to move this decimal point right there. And it's going to move 1, 2, 3, 4 spaces. So I moved it 4 spaces. I'm going to keep track of that movement, and I'm going to make up for it. So I now have the number 3.16. Now, the change I need to keep track of is this. Before, I had a very, very small, tiny number, right? And I just made that number slightly bigger. So if I take something small and I make it bigger, think of it like taking a loan from the bank. I'm taking a loan from the bank to make my number bigger, so I owe the bank 4 decimal spaces. So the way I'm going to do this is I'm going to write 3.16 times 10 to the power of -4. All right? Because I took a small number, I made it bigger, that means I owe some money. Now, let's go to the opposite case. We've got a big number. I have to move the decimal point right behind the first number, which is going to be 7. Again, we're reading from left to right, not manga America. We read left to right. So decimal point right behind the first number is going to be right behind the 4. Now, how many spaces does it move? Well, there's no decimal point in this number to begin with. It's just hiding. It starts over here. So it moves 1, 2, 3. Oops, make that 2 a little bit bigger. 3, 4 spaces again. So the number I now have is 4.78. Now, the way I think of this is I took a really big number and I made it smaller. It means I lost something, which means the bank owes me money for my losses. So 4.78 times 10 to the power of +4. All right. So if you take a small number and you make it bigger, the exponential change is minus. If you take a big number and you make it smaller, the exponential change gets added. So small to big, subtract, big to small, add. And that's the best way that's always worked for me. Some of you may be wondering, why don't we just use left to right rules? That can get a little bit tricky as we start doing more and more math with these. So that's why I like to keep the, if I'm going from small to big, I owe money. If I go from big to small, they owe me money thing. I think it works best in the mind. So let's go to another example down here. We have 0.000316 times 10 to the power of -7. This is not in true scientific notation because the decimal point is not behind the first number. It's close, almost there, just not quite. So I'm going to move 1, 2, 3, 4 spaces, 2 right behind the 3. I now have 3.16. I took a small number and I made it bigger, which means I'm going to subtract. So I subtract 4, the 4 decimal spaces, from the existing exponent. So I just subtract another 4 from 7. -7 minus 4 is 10 to the power of -11. And that's my final answer here. Now let's go to this one. I need to move the decimal point right behind the 4, so I start from back here. 1, 2, 3, 4. So now I have 4.78. Again, big number got made smaller. They owe me money. So I'm going to add 4 to the existing exponent instead of subtracting. 7 plus 4 is +11. All right, so that's scientific notation in a nutshell. I hope you guys are understanding how it works. If you have any questions, let me know on Moodle, and I will see you in class.